Have you ever wanted to 3D print your own RC car? Well, additive manufacturing can help you do that. Hi, my name is Hamza. Welcome to my senior TED Talk. So why am I doing my TED Talk and thesis on additive manufacturing? Well, I spend a large majority of my time already doing this. This is on the far left, there's a mostly 3D printed RC car. And if you want to pass it around, here it is. It's pretty cool to touch. This is for my senior project. I'm making an entirely 3D printed RC car. So this this is the part of the differential for that remote control car. That's a render of it, and this is a fully 3D printed rocket engine, which is super cool, I think. This is what I want to do in my future. It was 3D printed in the single part using an AI generative design process. So, all right, so the question I've been answering is, how is additive manufacturing currently being used and how might it revolutionize the manufacturing industry? So what is additive manufacturing? Additive manufacturing is a group of processes that build up objects using layers. And think about this shape being split into a million different layers and then stacked on top of each other, just like bricks. I'll also be talking about traditional manufacturing. So this is an example of a CNC machine, part of the subtractive manufacturing processes, which is just taking away material from a larger piece of material to create an object. And this is an example of an injection molded part, which is literally just having a mold and injecting stuff into it. It's mainly used with plastic. Cool. Some things I've been researching over to make this TED Talk is how it's currently used. So this is a skull that has a prosthetic where the bone used to be, and it's used a lot in the medical field, and it's also used in the aerospace fields. Think about like printing really strong and lightweight parts, and you can also print really customized parts such as shoe insoles that fit the customer perfectly. I also researched how it will be used in the future. So this is a render of the Hikaro 1 or 2 missions to the moon, and these main boosters here were actually additive manufactured in Durango by Agile Space Industries, which is really cool. I also researched how it compares to other manufacturing, like the CNC machine, like we talked about in the other slide. My first claim is print complexity. So this is a really complex shape, as you can tell. This is a section of it. This would be on the inside of the part. It could only really be printed with additive manufacturing. If you're printing, or if you're cutting it with subtractive manufacturing, you would probably cut it into a bunch of different pieces, right? And then bond them together, or layers. You could print them in layers, and then that sort of just sounds like additive manufacturing, right? So this is another image of a really complex internal structure. This is under a structural analysis. The red parts are the pieces that are under load. And as you can see, the internal structure is actually taking a large majority of that load. The outside is still just green and blue, but this inside is all red. It's taking all the load. But this part would be similar in strength as if this piece was solid. But as you can see, it's not solid. So we can print much lighter parts that are still just as strong. my second claim is rapid prototyping. So we can prototype much faster using additive manufacturing. We can go from a really basic prototype, like the one on the far left, all the way to a final product much faster. Now this helps improve it improves how we can invent things much faster, innovation. We can innovate much faster. This can help improve the world because we can make new stuff, helping people much faster. As you can see on my RC car, wherever it is, it has a bunch of additive manufactured parts. All those parts have been printed made 20 times each. So it was really helpful to prototype with additive manufacturing. And also it was also made a really good final product also. So for my third claim, efficiency and cost. So additive manufacturing can also improve the efficiency and cost of manufacturing products. So as you can see, the CNC machine, all the shavings are just flying everywhere because we're wasting a whole bunch of material. This part could be made with injection molding or subtractive manufacturing. As you can see, it's 2 kilograms. Now this part, this topology optimized part, could only be 3D printed using additive manufacturing. And as you can see, it's much lighter. And obviously it's still just as strong. So we increased our weight efficiency and how much material we're using. And on the far left, this is a form of additive manufacturing called electron beam manufacturing. It's kind of like welding. I just thought it's cool. For my fourth claim is transportability. So now, additive manufacturing machines can actually be so cheap and lightweight and transportable that you can have them on your desktop. So with all other processes, it's nearly impossible to do that. You can also have in-space production. This can help with space exploration. Like as last week, you know, if you didn't hear the Artemis 2 mission, their toilet broke, right? They managed to fix it, but if they needed a part and they had a 3D printer, NASA could just send up a file and they could print it right on board and fix their toilet. With other manufacturing methods, that's impossible. And here is a future render of a house being built on the moon using additive manufacturing. So we can actually make the concrete on the moon, and so we don't have to ship materials there or anything. They're already there. We can, on Earth, we're already experimenting with having concrete and structures being built. People's homes and offices are being built with additive manufacturing. So why won't additive manufacturing replace traditional manufacturing? So subtractive and injection molding have much higher volume and overall strength than additive. So obviously with injection molding, we can print way higher volumes. Once you have a mold, you can print, or you can make parts like in just a few seconds and just keep cranking them out. And it's this sort of similar with CNC machining. And if you think if you're just CNC machining a solid block of titanium or something, it'll still just overall be stronger, but of course it won't be as lightweight. One of the processes that I think will emerge in the future much greater than all other processes is a hybrid of a whole bunch of processes. So this is a CNC machine cutting into an additive manufactured part. We can still get those really strong internal structures, keeping the part super lightweight, while we can also get the really nice surface finish and tolerances using our CNC machine. And this is actually the rocket engine from the spaceship we looked at earlier, the moon landers, Caro 1 and 2. This is also hybrid additive subtractive manufactured. So this cone has the additive manufactured part with all the tubing, the cooling that it requires inside of that. And then we also have the really nice, smooth, high tolerance part at the top, which is good. All right, so why should you care? Well, additive manufacturing is growing a lot. As you can see, this is a future projection. And from 2023 to 2025, the additive manufacturing industry grew by 24%. So it'll become a very huge thing in the future. Right now, of course, it's much, much smaller than subtractive or injection molding, etc. But in the future, it'll be much better. And I also hope to be a part of the additive manufacturing group of engineers later in life. So thank you for listening to my